SuGRE-1 space mission. I'm Cherie, I'm here with Neil Murray at the offices of Dynamic Imaging Analytics based at Bletchley Park Science and Innovation Centre. So tell us, what is SuGRE-1?
So I was contacted by some of my old colleagues in the USA some months ago now, and they asked if we wanted to fly some of our technology on their next sounding rocket. And we said obviously yes, that'd be fantastic, we'd love to do that. And we sat around and thought, what could we put on there? And we will, during the flight, experience microgravity for up to 5 minutes or so. So we thought it'd be really cool to record some bits floating around and knocking into each other.
So what is microgravity?
So microgravity is a condition that exists when everything in the same area is moving at the same speed and direction as each other, so it appears weightless. So the spacecraft is moving and the bits inside are moving at the same time, a bit like the people floating around on the ISS.
And why did you decide to call it SuGRE-1?
So we called it SuGRE-1 because we thought it'd be great if the school children could make these sculptures, so we don't have to do them, we could outsource that job and hopefully inspire some creativity and engineers and scientists of the future by getting them to design and manufacture their own sculptures that conform to a set of simple rules, and we'd fly them and film them. So SuGRE-1, S stands for schools, microgravity, rocket experiment. And
the U is because?
Because in engineering we use the symbol mu, which is a Greek letter, to symbolise the word micro.
Right, I see. Excellent. So you might have noticed that we have a scale model of a rocket above us. This is the WRXR rocket. And here you've got the boosters. These are going to get us into space. And the science payloads are going to be in this section here. And when we use the term payloads, we're basically referring to the equipment that's on board that's going to do the experiments. And the SuGRE-1 payload, the SuGRE-1 payload is going to be in this little blue section here. And we actually have a scale model here of a person holding the SuGRE-1 payload, and you've got a life-size version.
Yeah, sure. So this is 1-to-1, similar to the model that you see there. And so if you imagine the SuGRE-1 rocket is about the same width as my shoulders in reality.
Yeah, this is 20 metres, is that right?
So something like 20 metres tall, yeah.
Right. Cool. What are the challenges that you face in building SuGRE-1?
So one of the biggest ones that we've had is fitting in all the work that we've had to do to deliver the flight hardware and get that integrated into the rocket, amongst all the other jobs that we have, and with no budget as well. So there have been lots of late nights working away to get this built. We want to be an independent system from the rest of the experiments on the rocket and other systems, so that we aren't causing problems for other members of the team. So we've had to provide our own power source in the form of rechargeable batteries, which sits in a box next to the boxes like this, and these have to be sized to last for the duration of the flight, plus some margin for if we're delayed or
How
whatever.
long do you expect the flight to be?
So the flight time itself is about half an hour, but we have contingency in there for an extra hour, so we can set off early and record hopefully once the rocket's bobbing around on the ocean. So the biggest challenge has actually been the sculptures themselves. So we don't actually want them floating around and knocking into each other during the observation of the telescope. As you might imagine, even a small amount of mass banging into the walls will push the telescope off target, and that's a very bad thing. And so what we've had to design into the payload is a way of holding all the sculptures tightly together during the launch phase, and then once the telescope's finished doing its observation, to spring open and fire them out into the volume that we'll be filming in 3D. So that's been quite challenging to come up with a mechanism that will survive the up to 18 Gs of force at launch and vibration, stay shut and then open, and then also provide energy to the sculptures for them to come out. So they will fly out after the X-ray observation's finished, and we will film them all as they interact with each other. We expect them to lose all of their energy and stop moving after about 5 seconds. And then as the rocket re-enters the atmosphere, it'll be spinning in all different directions, and so they will go everywhere. It'd be interesting to see what happens.
Yeah, that'd be great. And you'll be filming all of that in 3D.
Absolutely.
Excellent. It's not just SuGRE-1 that's going to be on this space mission. There is going to be actually 3 different payloads. So the main payload is going to be provided by Pennsylvania State University. They're going to be looking, with an X-ray telescope, they're going to be looking at a supernova remnant, which is the bits that are left over after a star has exploded. And the Vela supernova remnant, that exploded about 12,000 years ago.
Take your word for that.
Yeah, but they're going to be putting a telescope up in space to look at that. So that's one experiment. A second experiment is by the Czech Technical University. They'll also be looking with different technologies at the Vela supernova remnant. And then the third payload is SuGRE-1. Yeah?
Yep.
And as you say, needs to work completely independently and not interrupt the other experiments that are on board.
Yes, of course. During the flight, they'll be sending their data back to the ground, whereas we won't have the opportunity to do that. So we'll have to record all of our data to a hard disk. So this is another challenge we've had to overcome in that what happens if the rocket hits the ocean hard and breaks that hard disk. So we're going to have to generate a backup during the descent phase. Also, the rocket may leak once it's floating on the ocean before recovery, so we need to make sure that our payload itself is watertight and remains so. Then the other challenge is mechanical, like most things going into space. It's quite an extreme and harsh environment on the way up. That this rocket can be doing 400 miles an hour in after 1 second from launch. And so we need to make sure that things just don't break on the way up. Also, there's a lot of vibration, so things can shake themselves to pieces. And so lots of attentions have to go into the design of this. So there's lots of parts made of metal that you'll see, not foam board as you see here. But when we see in the later videos the actual hardware, you'll see lots of aluminium and reinforcing structures. We've been very lucky to have a 3D printer, which allows us to use a variety of different materials to make things inside. So, for example, the batteries are housed in a flexible resin that we've printed. So the batteries are held in place quite firmly, but with enough room to manoeuvre, so that when they heat up during use, that expansion doesn't push against the metal and cause an explosive situation,
And
which is bad.
3D printing is one of the kind of suggestions for making the sculptures, right?
Absolutely, yeah. So as a trial run, we had my nieces came over and made some sculptures. Over the course of 2 days, they came, visited, designed them the first day, and the second day, well, they printed them overnight, and the second day they came in and painted them.
So it can be done quite quickly.
You can done very quickly.
You can design and make a sculpture quite quickly.
Yeah, sure. I mean, we realise that not everyone has access to a 3D printer.
Yeah.
So that's why we want people to be creative and come up with all sorts of solutions for making these things, and so there's a variety of options that they can use to manufacture them.
Excellent, excellent. So this is going to be launching from the Marshall Islands in the Pacific Ocean, is that right?
Yes.
In April.
Yep.
So what's the timeline? When do you need the sculptures by?
So we need to get the sculptures in there at least a few weeks before launch, and obviously I need to get there with them, and so we've said that we need to have received them here by the 1st of February.
And you need 2 copies?
We need a flight model and a flight spare.
Excellent.
Of course.
And Roy's going to tell us much more about what's required and what the challenge is and all the specific details in the next video. So thank you, Neil, and I'm sure we'll see you again when we're building SuGRE-1.
Sure you will.
Thanks.
Thank you.